All right, well, we've hit our first glitch of the day. Apparently, the video conference link has had a technical difficulty in Paris, which is where our international partners were going to link up with us. But we do think we could get it addressed in about 10 minutes. So we're going to take a 10-minute break.
Well, wait a minute. Why don't, instead of taking a break this early, why don't we ask some questions?
Yes.
Of,
that's a great idea.
Of Doug here,
yeah.
If you don't mind.
Yeah,
maybe we can let him.
Both of you. I'll start out with one while my colleagues are thinking here, if that's all right. I was struck on the LOC calculations that on the shuttle that we know a lot about, we show a range of uncertainty about a factor of 2, 160 to 270, and yet for the Constellation it's 1,200 or 2,850. And I'm not trying to nitpick, but just the question is, if we're so uncertain about today's system, how can we determine with certainty or anything approaching certainty?
Well, that's a great question, and it's probably in the way that we chose to express it in the charts. The number that we cite for Orion Ares 1 is the mean, and there is a distribution around that that would have a low and a high value. It could be as low as a certain number and as high as a certain number. I don't have those numbers with me today. The way we use these numbers is really in comparison with alternatives in the design that we might choose for various systems. The probability numbers are really informing the design. And so as we do comparative analyses, really the absolute number is less important than as long as the analysis is done in comparing the alternatives in a apples to apples way. That's where we would get the most value out of those numbers.
Thank you. My colleagues?
Certainly,
Okay.
certainly we can provide
Wanda's got a
backup
question
to
here.
too. We'll provide backup.
Yeah, and in particular, it'd be interesting to look at what are usually called the P5 and P95, you know, the statistically significant lower and upper bounds of those numbers to get some insight as well.
Wanda?
Yes, you indicated you had a 65% confidence in the cost numbers. What's your confidence in the schedule of March 2015?
Right now, the model that we have the most history with is the cost. We're actually developing a schedule model to get that type of calculation, and we're working through that with PA&E at headquarters to get to a point where we have a good schedule calculation in terms of probability. Our schedule, we are actually at this point we have moved from internal dates that we were planning for to our commitment date of March 2015. So we're realigning our internal schedules right at this moment. We know we have areas we need to work, and so it's a tight schedule. That's certain.
Chris?
Thank you. Your chart that you showed us on influence of key drivers on architecture selection compared loss of crew probabilities for EELVs to Ares 1 and argued that it was really that distinction, if I understood the chart properly, that preferred Ares 1 to EELVs. You've just said in your remark that there's a range, of course, with respect to that estimate for loss of crew for Ares 1. Does that, does the 1 sigma and that extend over into the ELV range? Can you give us some sense of whether there's really a statistically significant difference between the two?
I think in terms of the numbers that we showed you, the relative differences are important. There are certainly probabilities associated with each one, and once again, I don't think we have those numbers here, but I think they were calculated in a apples to apples sense.
We will get those numbers.
Yeah, we'll get you the background on that.
It's important to note, though, that the methodology used to assess all of the launch vehicle options was a common methodology. That's what ESAS really was about. It was to take the synthesis of prior analysis and bring it apples to apples against a basic set of mission requirements and compare as on a level playing field as best we could.
Roy?
Yeah, I have a question about the Orion. I know the nominal plan right now is to land in the water, but I noted in your charts that in a contingency you can land on terra firma, and if that's the case, I'm wondering why we don't go back to that now.
The reason is, in a contingency sense, we don't carry as much redundancy in the systems. If we use it as primary mode of landing, we would have a lot more redundancy in it. It'd weigh a lot more, and that's really the primary reason that we went to the water landing. We wanted to make sure that we had the capability to land the crew without injury, but there's not the level of redundancy in systems to get to making that a nominal case.
Okay, so even in the reduction of crew size from 6 to 4, that's still the case? I mean, you're still too heavy to land on land.
The thing is that we don't want to lose the capability associated with 6 crew. So if we fill up that with weight, then you don't get to that point again. And also, it's important in the time frame that we'd be traveling to space station that we are able to carry up mass and down mass. So we don't want to give up the mass, any mass savings that you'd have there. We don't want to give all that up to that capability or to get away from the original requirements.
Mr. Chair, our link is back up with France. Unfortunately, we're only going to have an audio, and we need to cut over right now. Sorry, Doug.
Hey, Jeff and Doug, thank you very much.